Okay, today let us do a problem. This is one of the examples or one of the practice yourself problem from the book, and there's some added questions to it. So let us go for this one. Based on the data from the National Health Survey, women between ages of 18 and 24 have an average systolic blood pressures in millimeter mercury of 114.8 with a standard deviation of 13.1. Okay. So systolic blood pressure for women between ages of 18 to 24 follow normal distribution. So this is a normal distribution since the standard deviation is given, since nothing has been said about standard deviation. So we by default consider this standard deviation to be the population standard deviation, okay? And the average means here also we will consider this as population average, okay, or population mean of 114.8. If a woman is randomly selected, what is the probability that her blood pressure is above 120 millimeter of mercury? Okay, so let us write that down at first. First of all, here, this is the question. Okay, so mean equals to 114.8 and sigma standard deviation is 13.1. Okay, so then you can simply say that this distribution follows a normal distribution 114.8 and sigma is 13.1. okay, so that's a normal distribution. Now let's simply head over to geogebra.org/classic hash probability. Here let us write down the mean, which is 114.8 and the standard deviation is 13.1. that looks fine until now. Okay, so here it is saying if a woman is randomly selected, what is the probability that her blood pressure is above 120 millimeter of above that level. Okay, so question A, x equals to 120 mm. We are simply finding out probability is x is greater than is above means x is greater than 120, right? Above 120. So what is this? So for this one, let us head over to that website and let us just simply go for this right-sided distribution, since we just wanted to go up to here, right? Yeah, something just like this one. So this would be 120. So that would be 0.3457. 0.3457 means approximately 34.57% of the women of that age group 18 to 24 will have more than 120 level. Okay, now for the second one, B, here it is saying a doctor wishes to determine the 80th percentile of blood pressure readings. What would be the blood pressure reading be? So here percentile always means the probability, okay, the priority area. We mean this area. Okay, so 80th percentile means B. 80th percentile means, let's go for this one. So yeah, 80th percentile means x is less than x, and we just want 0.8. So the population beneath or underneath that number x should give us the probability area 0.8. So basically we go for this one. Okay, we go for this one and we tend to find out this point, this moving point. Okay, so here let us write down 0.8, since that was 80th percentile, so that would be 125.82. 125.82. So let us write that down. Okay, so this is x equals to 125.82. 825. Yeah, so let's go for this one. So this should be the answer for this one. So it's quite easy. Now let's go for C, number C. Here you can see that everything in question C looks like that of question B. However, there is a sample of 40 women. Okay, so for that one, we need to go for sampling distribution. Okay, so sampling distribution, to go for that, the mean is always the same. We are basically going for this kind of distribution. Okay, the mean mu x bar is simply mu, okay, which is again the same thing, 114.8, right? And sigma x bar is simply the original population mean divided by root under n, okay, which is what, 13.1 divided by root n means 40, right? In that case, that was 40. Yeah, there were 40 women, so we go for that one. 13.1 divided by square root of 40. 2.0713. 2.0713. So that's 2.0713. All right, so that's the standard deviation for this sampling distribution. So now let us plug in both of these two over there in that thing. Okay, so that was the standard deviation, okay, for that sampling distribution. And then what is this saying is we just want the 80th percentile. Okay, so 0.8 would be 116.54. 116.54. Okay, so for this one, probability of x bar is less than x bar is 0.8. So x bar equals to 116. Okay, so that's the thing. All right, looks good. Percentiles. Okay, a doctor wishes to determine the middle 95th percentile of the blood pressure readings. So what is the cutoff reading? Okay, so middle 95th percentile. So D. Okay, D. 95 percentile. Mid of 95 percentile means what? Is 95 divided by 2 is what? 95 means, yeah, 47.5. 47.5 is the percentile. Percent is what it is trying to say. So we just need something just like x is less than or equals to x and equals to 0.475. Okay, so that's what we want. Okay, so for that, now we just need to change this thing again. That was 13.1, since it is not considering about the sample size. Okay, so that's it. So, and this would be then 0.475. Okay, so that's it. So that would be 113.99. 113.99. So the cutoff point is x equals to 113.99. Okay. So this is the way how you use GeoGebra's probability calculator to come up with to work with problems on percentiles or probabilities. Thank you.